I'm going to talk about population biology of hedgehog fungus, fungus Trichophyton Erinaceus, and emerging cause of dermatophytosis nowadays. as you As you maybe remember from talk of VTech and also from other talks, Trichophyton Erinaceus, it's part of Trichophyton benhamii complex. It's closely related to Trichophyton verrucosum, the cattle-associated fungus, and to Trichophyton erythrophon, which host spectrum is unknown. As you know from VTech's presentation, we did quite comprehensive work on that Trichophyton benhamii complex, but there is still a lot of work to do. So now in next study, we continue with very interesting species, Trichophyton erinaceus, which became emerging pathogen. The main host of Trichophyton erinaceus, it's a hedgehog. It's a hedgehog fungus. This species is mainly reported for two species of hedgehog, from a European hedgehog and a four-toed hedgehog. European hedgehog has European distribution, and four-toed hedgehog you can find in Central and East Africa. So even distribution of fungus, it's related to distribution of a main host. So the first isolates of Trichophyton erinaceus we get from Africa, from Central, especially from Kenya and East Africa, and also from Europe, from Britain. And mainly, and also what is quite surprising, from New Zealand. But the reason is that hedgehog, the European hedgehog, was introduced to Europe, to New Zealand from Europe in 19th century. But nowadays, Trichophyton erinaceus becoming more and more important, and that's because of I cannot see what I see at my computer. Okay, now it's working. It's because that four-toed hedgehog became a very famous pet animals, and that hedgehog were spreading to many households all over the world, and also its pathogen were spreading all over the world. So nowadays there are cases reported from almost all over the world. Prevalence in hedgehogs are quite high. In hedgehog population, the infections are mainly asymptomatic for hedgehogs, and you can see that it's up to 45% in wild population, and also it's very high in pets. There is a poor macromorphology, poor variability in macromorphology, as you can see here. But Heidelmann in 2010, he reported the variability in ITS region, and he split Trichophyton Erinaceei into two populations which were specific for different hosts. So we were very curious about that, and we decided to look at that closer. We do same approach as for Trichophyton Benhami complex. So we collected 170 isolates from all over the world, from Europe, Africa, also from New Zealand, and a few from Japan. We used 7 microsatellite loci, and we did morphology work and multigene phylogeny. Okay, here you can see displayed 12 genotypes, which we found using microsatellite markers. And you can see that they are not really clear structure. We can distinguish like 4 or maybe 5 clusters inside. One is specific for four-toed hedgehog, which is also pet animal and wild-living hedgehog. This strain is weird. It has also different special genotype, ITS genotype, and also TFA genotype. Then this one strain, it was collected from four-toed hedgehog in Africa, and the rest of strains which were clustering like this, were collected from a wild-living European hedgehog in mainly Europe. Maybe it's not that clear, but you can see that we can separate the whole population into 2 main clusters. And this also what the another analysis were supported. I use the Bayesian clustering method to find out how many clusters are inside, and the analysis proved just that there are just 2 clusters inside a complex. But you can see that there are 2 clonal lineages, and both are specific for its own host. One is specific for European hedgehog, and one for four-toed hedgehog in Africa. And these 2 clonal lineages, they have also different micromorphology. You can see that a lineage isolated from a four-toed hedgehog has a longer conidiophores, a lot of macroconidia, and also different shape of microconidia than strains from European hedgehog, which has very, very short conidiophores like this, and macroconidia are there, but they are very rare, and microconidia are mostly clavate. It's also okay. This is also what this was also supported by wild of microconidia. You can see that cluster which is from four-toed hedgehog has wider conidia than a cluster from a European hedgehog, and these are intermediate strains. These are not from clonal lineages. So these two lineages, they have also a different molting type idiomorph. For four-toed hedgehog, we found only one idiomorph, and for four-toed for European hedgehog, we found only two idiomorph. So the thing is that the study of Heidelmann was good, but he didn't consider these intermediate genotypes. So we cannot really say that these two clonal lineages are different species, because there are still some intermediate strains which has intermediate morphology, and they are not clearly separate from each other. The question is, what will happen in the future? Maybe these two clonal lineages became a new species one day, but now it's not their time. Since there are many species of hedgehog, it could be interesting to get more isolates and to see if there are more lineages which are specific for another hedgehogs species, because this Trichophyton Erinaceus was already isolated also from North African hedgehog. So, but unfortunately we don't have that isolate. And till the end, I would like to thank you, to especially Vidhubka. So, are there some questions? So, the microsatellite analysis didn't contain isolates from four-toed hedgehogs imported into the US. Are they African types? Well, yeah, we don't have isolates from US, unfortunately. This is probably, the first question is not a question on me, or is it? Is the multilocus database for dermatophytes available worldwide? Well, I don't know. And did you do multi experiments between both growth? Yes, I did some multi experiments, and I did some pseudo-ascomata, but they were out of ascospores, so I was not successful.